Okay. So anyways, guys, you can't hear anything, Kelsey? Okay, maybe your volume is down. Check your volume. Yeah, check your volume. I can hear everybody perfectly clear. I think they can hear me too. Okay. So guys, lesson 4.1 is on writing Hindu Arabic numbers in expanded form using base 10. And we're going to also do this in reverse. Given the expanded form, we're going to condense it into a Hindu Arabic number. Okay, so since we're talking about the history of numbers, guys, we have to go a little bit into the history. A number is basically a representation to answer the question, how many or how much? Like if you go back into prehistoric times, it was how many buffaloes did I kill in the field? Okay, so they would use tally marks in some instances. Now, as we go down through history, how many bushels of wheat does the farmer have, or can the farmer produce? So, or how much would the bushels of wheat cost? You know, things like that. So basically, a number answers the question. It's a representation that answers the question, how much or how many? Now, if I was in the classroom with you, I would show you in the book where we have different representations of numbers, okay? So if you go through chapter 4, all right, you will see different numerations from different places across the world. Now, our numbering system, guys, is referred to as the Hindu Arabic numbers because they are descended from that part of the world. Now, our Hindu Arabic number system is a base 10 number system that has 10 digits. What are those 10 digits? 0, 1, why am I writing 2 ones? 2, 3, and so forth and so on up to 9. So 10 digits is what represents the numbers that we're familiar with, and those numbers that are referred to as the Hindu Arabic numbers. So using these 10 digits, we can create numbers, any number we need using just those 10 digits in base 10, okay? Now, throughout the remainder of this chapter, you will notice we use the base 10 over and over again, so get used to hearing that. The Hindu Arabic term, we use that over and over as well, okay? Now, some of the numeration that you guys will notice, okay, is the Mayan number system. I'm gonna mention it, but we're not going to be using it. The Mayan numbering system, guys, uses a series of dots, okay, and segments. For example, the dots, you start with 1, 2, 3, 4 dots, 1 dot, 2 dot, 3 dot, 4 dots. And then when you get to 5, you use a segment. So if you wanted to write the number 6, you would use a dot and a segment. That's the Mayan number. We're not doing that, guys, okay? Now, there's another one called the Babylonian. The Babylonian uses a series of arrows, depending on which way the arrows are pointing, that determines the value of the digit. We're not going to learn that either. And by the way, typically, the person who writes the final exam, because it's a comprehensive final exam put out by the department, okay, you will see some of these questions on there. If you see them on there, you bring it to my attention, and I will make sure to go ahead and take care of you guys with those questions, because I firmly believe we need to use information that we can actually use in our regular lives, okay, guys? So here's a numbering system that we are going to use, and that is the Egyptian numbering system, or the Egyptian hieroglyphics. That's going to come up later on, but I just wanted to mention this to you. It's got a staff, it's got a heel bone, it's got the astonished person. By the way, the astonished person is the million number, because the person is astonished that they just won $1 million. That's coming up at the end of the chapter. So we're going to talk about that one. And of course, guys, our favorite, everybody uses this around Super Bowl time, the Roman numeral system, because most people, they're not comfortable with this. The only time they encounter it is during Super Bowl season. Seriously, the I, V, X, L, C, D, and M, that's coming up towards the end of the chapter as well. So we are going to be learning these. And if we go through the chapter in the textbook, they have the Braille number system, excuse me, they have the Ionic Greek number system, you know, delta, gamma, beta, and things like that, and lots of other numerations from across the world. But guys, what I want to focus on is basically the topics that you guys need to learn that you can actually use in your regular life. So we're going to start with lesson 4.1, guys, like I said, where we are going to convert Hindu Arabic numbers in extended form using base 10. So lesson 4.1 is on writing Hindu Arabic numbers in expanded form using base 10. So what in the world am I talking about? So if you're given a number like 37,452, you have to express this in base 10. This is asking you to break down this number in multiples of base 10. So what multiples of base 10 makes up 37,452? So this number is made up of 30,000, guys, 30,000 plus 7,000 plus 400 plus 50 plus 2. Now, 30,000 is basically 3 times 10 to the what power? 1, 2, 3, 4th power. So if you were to grab your calculator and you multiply 3 times 10 to the 4th power, that would give you 30,000. So when we write the 30,000 and multiples of base 10, 3 times 10 to the 4th power is what it is. And then we're going to do the same thing with the 7,000. 7,000 would be 7 times 10 to the 3rd power. Now, what you will start noticing is that, guys, the powers of 10, notice, they are moving in descending order of powers, as in 4, 3, 2, and of course the next one is going to be the 1st power. But do we really need to put the 1st power there? Nope, we don't need to put the 1st power there. And then last but not least, okay, the 2 times, rather than 10 to the 0 power, because 10 to the 0 power is equal to 1, you don't use that, you use 1 instead. And yes, you do have to put the 1 there, okay? So guys, pretty much this would reflect our answer when 37,452 is written in expanded form using base 10. This would be our answer, guys. Yeah, it's easy, but you got to know what you're doing, okay? So what if we have a whole bunch of zeros in there? What happens when we have a whole bunch of zeros? Let me show you one with a whole bunch of zeros. 700,000. Okay, you know what? I'm just going to put 43, okay? I'm not going to rewrite the number. So guys, be careful with this one. What is this number made up of? 700,000 plus 40 plus 3. That's all you need to write out. 700,000 plus 40 plus 3. Write each one of those numbers in base 10. So the 700,000 will be 7 times 10 to the 4th power. The 40 will be 4 times 10. And then the 3 will be 3 times 1. And you're done. Now, some of you are probably saying, well, what about the zeros? You don't have to worry about them. Why? Because when you multiply by 0, you get the 0 right back. Yeah, anything multiplied by 0 is just 0. So you don't worry about it. Plain and simple is that, guys. Okay? Now, we can also...
Excuse me. Would that, the 700,000, wouldn't it be times 10 to the 5th?
Oh, Shazam, you got me. Oh, you're paying attention. That's awesome. Very good. All right, guys. So sometimes, you know, if I'm talking too much and too much excitement, I get all sidetracked. Okay, there we go. Good catch, though. All right, guys. So I am going to do this now in reverse. What happens when you are given the number in expanded form and you have to condense it into a Hindu Arabic number, guys, okay? And so if you get something like this, 7 times 10 to the third power plus 5 times 10 plus 4, a number like this, guys, what do? You grab your calculator, type it into the calculator, people. Yeah, exactly like you see it. Plug it into the calculator and the calculator will give you the answer. So you don't even have to worry about one like this. Now, if you want to work it out, you can, because 10 to the third is 1,000. So that's 7 times 1,000. So that's going to give you 7,000. And then 10, 5 times 10 is 50, okay? And then you add the 4 to that. So what are you going to end up with? 7,054. Oops. Let's put the 0 in there. 7,054. And yes, try typing it into your calculator. You should be able to get the answer, guys. One more like this. Now, this next one right here is 6 times 10 to the 5th plus 2 times 10 to the 3rd plus 8 times 10 and then plus 2 times 1. Okay, so just like with the previous one, you can go ahead and just store it on your calculator and let the calculator do it for you, or you can work it out by yourself. Now, for the first one, 10 to the 5th power, guys, is 100,000. So that's going to give you 600,000. All right, and then 10 to the 3rd power is 1,000, so that's 2 times 1,000. And 2 times 1,000 is 2,000. And then 8 times 10 is 80. 2 times 1 is 2. So you're just going to add the 80 and the 2. So the answer is going to turn out to be 602,082. All right, 602,082. And there's your answer. And that's it. That's writing Hindu Arabic numbers, guys, in expanded form and doing it in reverse. So we take the expanded form and rewrite it in condensed form as a Hindu Arabic number. Any questions, guys? That's it for lesson 4.1. Lesson 4.1 is the easiest one, guys. Yeah, it is seriously the easiest part. All right, so here we go. I am going to now go into lesson 4.2, which is where the bulk of the work is coming from, guys. Lesson 4.2. We're looking at numbers. You guys, you've got to pay attention to this one right here. This is going to be hard. It's going to take some getting used to. Numbers and other bases. Now, remember, we just finished talking about base 10. So now we are in other bases. What other bases are we talking about? Base 2, base 3, base 4, base 5. Yes. So guys, let me start you off with this. Computer language. If we take the number 21, we type it into a computer, guys. The computer doesn't read 21. The computer, okay, through computer coding, translates this number into base 2. A series of ones and zeros so that the computer can read this, guys. So 21 is converted into ones and zeros for the computer to be able to process the 21. So the computer doesn't read 21. It reads a series of ones and zeros, meaning 1 is on, 0 is off, or vice versa, one of those two, okay? So guys, how, through coding, do they convert 21 to a series of ones and zeros? Remember, I just mentioned that this is in base 2. And because we're talking about base 2, notice first and foremost, there's only 2 digits in base 2. And those 2 digits are both less than 2, 1 and 0. We don't have a 2-digit because, guys, listen, how many digits are in 2? Okay, 2 digits. That's it, zeros and ones. All right, so how do we do this? First and foremost, guys, we're going to list the place values in the base. Now, we're going to list the place values until we have a number that is close to this number we're trying to convert without going over it. By the way, guys, You need to pay attention. This is the first one I'm doing. It's going to take at least 3 to 4 examples for you to truly get this. So be patient, okay? So guys, here we go. I'm going to take 2 and raise it to the 0 power. Anything raised to the 0 power is 1. By the way, this is very similar to what I was doing earlier with base 10. You know how in base 10, the powers are going in descending order of powers? Same thing here, guys. I'm not in base 10 anymore. I'm in base 2. So I'm writing out the base with its power. And I'm going to keep doing this until I get to a number that is very close to the number I'm trying to convert without going over it. So I'm writing out the place values. 2 to the second is 4. 2 to the third, that's 8. 2 to the fourth, that's 16. I'm going to have to stop here. Why? Because 2 to the fifth, that's going to give me 32, and that's too large. So guys, listen to this. So now we have the place values written out, okay? The next step is to use these digits right here. Let's count out the digits. We have 1, 2, 3, 4, 5 digits. And we're going to use these 5 digits to create the number 21, starting with the largest value. So in order to create the number 21, think of this as change. You have to give out change, okay, guys? If you had a $20 bill and you had to give out change for the $20 bill, you would start with the largest denomination. Same thing here. If you have 21 and you need to use 16, 8, 4, 2, and 1 to create it, you're going to start with the largest number. What's the largest number? 16. So we're going to need 116 to make up the number 21. So if you got 21 and you subtract 16 from it, what are you left with? 5. The next number down is 8. 8 is greater than 5, so we don't need to use an 8 because it's greater than 5. Now, the next number down is 4. We need a 4 in order to create the number 5. So we need 1 4. If we subtract the 4 from 5, that leaves us with 1. Obviously, 2 is greater than 1, so we don't need a 2, but we do need a 1. So guys, what this is telling me is this. If I take 1, I add 4, I add 16, that's going to give me this number 21. So the number 21 as a base 2 number would be 1 0 1 0 1. That's what the computer reads when somebody types 21 into the computer. And guys, we refer to this as a binary digit because it's made up of 2 digits, 0 and 1. I'm pausing, dramatic pause here because I want you guys to try and take that in. By the way, I stopped writing the steps because I didn't have enough room at the bottom. So guys, 10101. Oh, I forgot to put the base. You have to include the base as a subscript. I'm going to write those things down for you too. 10101 would be 21 in base 2. Yep. And that's what we're doing. Yeah, I hear you, Jennifer. Like I said, you have to give it 3 or 4 examples for you to get used to it. So I will take my time with you. All right. Don't ask questions yet, guys. Wait until I get through example number 3, and then you can start asking your questions. It should become clearer to you later on. All right. So I am going to erase this so I can move on. By the way, that 10101, that's a palindrome, guys. It's the same number forwards and backwards. It's a palindrome. All right, guys. So I gave you step 1. I never gave you step 2. So here comes step 2. Step 2, we're going to divide, starting with the largest digit. Okay, so that's step number 2. And then once we're done with the division with the place value, starting with the largest digit, okay, we're going to now write the number in the new base. And guys, when you write your number in the new base, you want to make sure you include the base as a subscript. So you can tell people this is what base I'm in. Okay. So now I am going to go through some examples, guys, slowly, so we can get this. All right. So I'm going to clear this out. And here we go. I'm going to show you an alternate way to do this too. Remind me, and I'll show you a different way to do this, okay? So here we go, guys. This is example 2, 19 to base 3. This doesn't mean you do 3 goes into 19 6 times, 1 left over. No, okay? So we're going to write out the place value for 3, guys, for base 3. So in base 3, we do 3 to the 0, which is 1. We are going to keep writing the place values until we get to a number that is close to 19 without going over 19. 3 to the second is 9. Well, if we go to 3 to the third, everybody, 3 to the third is going to give us 27. So that's not going to work out. So we stop right there. So guys, what do you notice? We have 3 digits. So we're going to use those 3 digits to create the number 19. So here we go. Here's the division. Whoops. 9 divided into 19. How many times? 2 times. 2 times 9 is 18. We subtract 18 from 19. That leaves us with 1. Then we move on to the next digit. Okay, so that means that we need 2 9s right there. Okay, we're going to move on to the next digit, guys. And the next digit down is 3. Can 3 go into 1, the remainder? No. So that's going to give us 0. And then we move on to the next digit. Can 1 go into 1? Absolutely. That's just 1. So guys, we're done with the division process. So what do we notice? This 2, 0, and 1 will make up the number 19. In other words, you need 2 9s and 1 1. 2 9s is 18. If you add 1 to 18, guys, that's going to give you the 19. So 19 as a base 3 number would include 2 9s, 0 3s, and a single 1. And this number is in base 3. 2 9s makes up 18, and then plus a 1 gives you 19. That was only the second example. Give it some time to permeate, guys. It takes some getting used to. Okay, like I said, I promise I was gonna show you another way of doing this. So let me show you another way of doing this, guys. You ready? Okay, here it goes, guys. I'm doing it on the side. Let me see here. Yeah, let's just do it here. Okay. We're in base 3, so we're gonna do division with this. 3 goes into 19. How many times? 6, remainder 1. 3 goes into 6. How many times? 2, remainder 0. So guys, here's the answer. 2, 0, 1. Did you see that? It works every time. Yeah. Every time. Of course, absolutely, Tania. Absolutely. All right, guys, so here comes the next one. All right. So this time we're going to do 52 to base, we want to do 3 again. Yeah, why not? Let's do 3. All right, guys. So the long way, we're going to write out the place values. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. Write out the place values. 3 to the third is 27. Okay, we can't go to the next one because it's going to be greater than 52. So we're going to stop here. We got 1, 2, 3, 4 digits. So we have to make sure, guys, when we write out this number, the answer in base 3 includes 4 digits. So you have to use every place value. That's what I'm trying to tell you, okay? So now we're going to start with the largest number and divide it into 52. 27 goes into 52. How many times? Once. You subtract 27 from 52, that leaves you with 25. Now we're going to go down to the next digit, okay? 9 goes into 25. How many times? 2 times. 2 times 9 is 18. We subtract, that leaves us with 7. Now you go down to the next digit, 3. 3 goes into 7. How many times? 2 times. 2 times 3 is 6. 7 minus 6 is 1. So guys, we're done. Here's the answer. 1, 2, 2, 1. In other words, to create the number 52, we need 127. We need 2 9s, 2 3s, and a 1 in base 3. So 1, 2, 2, 1, base 3. It's another palindrome, people. Ooh, what's up with these palindromes around here? Any questions, guys? No? Okay, so let me do it the other way I just did it, guys, okay?
Okay, that's gonna be my question.
Yeah. So here we go. Let me separate this. 3 goes into 52. How many times? Okay, now this one's a little harder because we got 2 digits here, okay? 3 goes into 5 once with 2 left over, so you would have a 22 there. So 3 goes into 22 how many times? 7 times with a remainder of 1. So in other words, if you take your calculator, you do 52 divided by 3, that's going to give you 17 point something. 17 is the whole number. 17 times 3 is 51. And if you take 52 minus 51, that leaves you with a remainder of 1, guys. So let's do it again. 3 goes into 17. How many times? Well, that's 5 times with a remainder of 2. And then 3 goes into 5. How many times? Once with a remainder of 2. So what's the answer? 1, 2, 2, 2. And you go this way, guys, okay? Ooh, wait a minute, my pen is not writing right now. You go this way. My pen refuses to write, people. Okay, there it is, okay? And this, guys, on the side, it works every time, every time. So that was the third example. You guys are starting to get comfortable with those. You good? Okay, here comes example 4, guys. And then I'm going to let you try some on your own. All right, so 26 to base 4 this time. 26 to base 4. All right, so let's look. So on this one right here, guys, we write out the place value for base 4. 4 to the 0 is 1. 4 to the first power is 4. 4 to the second is 16. We can't go past 16 because that's very close to 26. And if we go past 16, it's going to be over 26. So we got 3 digits. So when we convert the 26, it's going to have 3 digits in it. So to create the number 26, we need a 16. So if we have 26, guys, we subtract 16 from it. What are we left with? 10. So we're going to need 2 4s. So 2 times 4 is 8. If we subtract 8 from 10, that leaves us with 2. So there's our answer in base 4. Now, how does it work out with that little side trick I showed you? Here it is. 4 goes into 26. How many times? Whoops, I'm setting it up the wrong way. That's the wrong way. 4 goes into 26. How many times? 6 times with a remainder of 2. 4 goes into 6 once with a remainder of 2. So 1, 2, 2. There's your answer. Okay, you guys ready to try some? Okay, you got to try some, guys, so you can get used to it, okay? All right, so you guys try this one right here. By the way, when we are converting these numbers, you notice every digit in the number is less than the base. So for this one, you're converting it to base 4. So every digit will be less than 4. So the number, the answer will include 0, 1, 2, 3. All the numbers less than 4. Give it a try, guys. See if you can come up with the correct answer. What is 63 and base 4? By the way, when you read these numbers, right now 63 is a base 10 number, so you say 63. But once you convert it to base 4, guys, you can't say the answer is 122. No, you have to say each digit individually. 1, 2, 2, base 4. All right, did anybody get it? Nobody got it? Ooh, I'm concerned. All right, so let me help you out. 4 to the 0, that's 1. 4 to the first power is 4. 4 to the second power is 16. Now, if we go to 4 to the third power, that's going to give us 64. So that's not going to work out, guys. So we ended up with 3 digits. So 63 has to include 3 digits. So we're going to take 16 divided into 63. 16 goes into 63 how many times? 3 times. 3 times 16 is 48. And we subtract, so that leaves us with 15. You go down to the next digit, 4. 4 goes into 15 how many times? 3 times. 3 times 4 is 12. 15 minus 12 leaves you with 3. So the answer for the problem is going to be 3, 3, and 3. Okay, wow. What is up tonight? Oh, it's base 4, guys. Did anybody get it?
Isn't it 3303?
Nope, 333. 333 base 4.
Never mind, you're right.
All right, guys, listen, I am going to now do some mental conversions, okay? And these are gonna go by very quickly. And the reason why I do this is because we are getting ready to do computations and other bases. And when we do these computation and other bases, you're gonna have to be able to convert these very quickly, okay? So let me go ahead and show you what I'm talking about. By the way, once we're done with the recording, I will go in and do some example problems with you. Okay, so guys, here we go. 9 to base 5. These are some mental conversion problems. 9 to base 5. Okay, guys, listen to this. These are easy. They're mental conversion, meaning it doesn't require that much work. So guys, here we go. Listen to this. The base is 5. Remember, this is all about division. 5 goes into 9. How many times? Once. With what left over? 4. And there's your answer. Yeah. Yeah, These are easy enough for you to do them mentally. Yep. Okay, let's do it again, guys. 8 to base 3. 14 base 5. I mean, not 14, 4 base 5. Okay, 8 to base 3, guys. So let's do it again. We're doing this mentally. So we are doing division. 3 goes into 8. How many times? 2 times. With what left over? 2. And just like that, we're done. Yeah. So to create the number 8, guys, you need 2 3s. 2 times 3 is 6. And 2 1s. 6 plus 2 is 8. All right, guys, let's do it again. 15 base 5. Oh, no, let's do base 4. Let's clear it out. Let's do base 4. All right, 4 goes into 15. How many times? 3 times. With what left over? 3. And there you go. I know. You need 3 4s and a 3 to create, and 3 1s to create the number 15. It's like saying you're making change for $20. You need a 10 and 2 5s to make up 20. Or if you're doing it for $50, one way to do it is to do 2 20s and 1 10. Yep. All right, guys. So next one. 19 to base 7. Okay, last one. 7 goes into 19, how many times? 2 times, with what left over? 5, base 7. And guys, that's it. So what if we had a larger number? Could we do this one, 87 to base 5? Can we do it in our head? No, that wouldn't work, because 5 goes into 8. That's 1 with, no, 5 goes into 87, I mean. 5 goes into 87 how many times? 17 times? No, we can't do that. Okay, that's not gonna work. 17 is greater than 5. You can't do it, guys, okay? So you actually gonna have to write out the place values. In base 5, 5 to the 0 is 1, 5 to the first is 5, 5 to the second is 25. So you're going to use these 3 digits to create the number 87. So if you're creating 87, you're going to need 3 25s. 3 25s is going to give you 75. So if you have 87, you minus 75, that's going to leave you with 12. So now, how many 5s do we need to create the number 12? We need 2 5s and 2 1s. Now we're done. And there you go. Okay, here's the last one, and we're gonna have to do it in the other direction, guys, okay? So this last one is 108 base 7. 108 base 7. Okay, so we can't just say 7 goes into 108, bam. No, it won't work like that, guys, because the number will be greater than 7. So you're gonna have to write the place values out. So, which reminds me, I forgot to do that little side trick with you guys. 7 to the 0 power is 1, 7 to the first power is 7, 7 to the second power is 49. So you need the digits 49, 7, 1 to create the number 108. How do we create the number 108 using 49, 7, and 1? Start with the largest digit, in this case 49. How many 49s are in 108? There's 2 of them. So 2 times 49, guys, is 98. If you subtract 98 from 108, that leaves you with 10. Now you got to create the 10 using the 7 and the 1. How many 7s are in 10? Or how many 7s do you need to create the number 10? 1. With what left over? 3. And there's your answer, guys. 2, 1, 3, and base 7. Now, if you want to do that little side trick, okay, let me go ahead and do it on the side for you. So we do 7 goes into 108. That's going to give you 1. Let me see. And that's 28. So that's going to leave you with 14. Hold on a second. No, 38. So that's going to give you 5 here. Remainder 3. And then 7 goes into 15. That's going to be 2 times. Remainder 1. So guys, there we go. 2, 1, 3. Bam. I know. It takes some time, guys, for you to get used to this because your brain is not used to doing these separate numbers. Now, the question you should be asking yourself, do we use this in regular life? Yes, we do. Like change. I was just talking about change. Another way we use it is through time. You know, 60 minutes makes up an hour. 60 seconds makes up a minute. Or you could use military time. 2,400 hours is a full day. Yeah. So we do use this. Okay, guys, so let's do it in reverse this time. In reverse. So now we're going to convert numbers in other bases to base 10. You will like this one because it involves multiplication and addition, whereas the other one involved division and subtraction. So people prefer to multiply and add rather than divide and subtract, guys. That's why you're going to enjoy this one, okay? And it'll make more sense to you. Step 1, just like before, list the place values of each digit. And by the way, guys, this is very similar to writing numbers in expanded form using base 10, okay? We're still using bases, guys. It's just that we're not in base 10 anymore. We're in other bases, okay? So list the place values of each digit, guys. Next, you're going to multiply each digit by its place value. And then the next step is to go ahead and add. Now, guys, this part, like I said, it's easy. And if you don't believe me, let me show you how easy it is, okay? So here we go. Let's say we have 43 and base 5, and we're trying to convert this to base 10. So we start with the 3. What's its place value? Its place value is 5 to the 0. And then the 4 is 5 to the first power. So essentially, when you write it out in expanded form, you would do 4 times 5 plus 3 times 1, just like we did with writing numbers in expanded form using base 10. So you would grab your calculator and plug this into your calculator, everybody. 4 times 5 is 20. 3 times 1 is 3. You add, you get 23. I know, that's easy. So here comes another one, guys. Now, this next one right here is 5-2 base 8. And you're converting this to base 10. Again, identify the place values. 2 is in the 8 to the 0 place value, which is the same thing as 1. Okay, 5 is in the, oops, that's supposed to be 8. 8 to the first power place value, which is the same thing as 8. So when you write it out in expanded form, it'll be 5 times 8 plus 2 times 1. 5 times 8 is 40. 2 times 1 is 2. We add, and what do we end up with? 42. Guys, I told you this was going to be easier. Yes. So let's see if you guys can do this one. 3, 2, 1, base 4. You guys give this one a try. Ooh, that 4 is too far. Needs to be closer. All right, there we go. You guys do this one and tell me the answer. You guys got it? What'd you get? Type it in the chat. What do you get? Nobody got it? 3? Come on, Tavion. We need more than that, Tavion. Maybe what? What'd you get, Tanio? Maybe what? What'd you get?
I thought I got it, but saying it out loud, I need 4 minutes.
That's okay. You can say it. Tavion got 111. Okay. 33, Christian Hall says. Anybody else? All right, guys. 68. Ooh, Shazam. We got to practice. Okay, let's practice, guys. Shazam. All right, guys. The 1 represents 4 to the 0. That's 1. The 2 represents 4 to the first power. That's 4. Okay. The 3 represents 4 to the second. So that's 16. So guys, when you write it out in expanded form, think about what we did earlier at the beginning of class. Expanded form. So this would be 3 times 4 squared plus 2 times 4 plus, I'm just going to put 1, guys, the last digit. I'm not going to do 1 times 1. That's just ridiculous. And then you throw that on your calculator. 4 squared is 16. 2 times 4 is 8. 3 times 16 is 48. You add the 8 and the 1 to it. So what do you end up with? 57. I know. Okay, maybe now you guys got it. Okay. Count out the place values, guys, just like we're doing with the previous one. You have to list the place values for every single digit, okay? So guys, here comes some more. 6, 7, base 8. You guys try this one. 6, 7, base 8. Come on, guys. Somebody. Oh, you guys should have gotten this one. I made this one easy for you. 55. Yes, Tavion. Yes, it is 55. So the 7 represents 8 to the 0. The 6 represents 8 to the first power. So this would be 6 times 8 plus 7. So 48 plus 7. And yes, that's 55. Bam. Here goes another one, guys. 1, 3, 2. And this one is going to be in base 4. 1, 3, 2, base 4. Go ahead, give it a try. And this is base 4, guys. Come on, somebody give me the answer. Anybody? Ooh, Tavion got it again. All right, Tavion, I think you got this. Okay, guys, so here we go. On this one, the 2 is in the 4 to the 0 place value. 3 is 4 to the first. 1 is 4 to the second. So basically, we have 1 times 4 to the second plus 3 times 4 plus 2. 4 to the second is 16. 3 times 4 is 12. And then plus 2. So you add everything up together. What do you get? 3. All right, guys, here's another one. I hope this time you really get it. 1011 base 2. 1011 base 2. 1011 base 2. Come on, guys. Okay, did somebody get it? Oh, let me see. Okay, Jules said 30. Okay, Jennifer says 32. Tonio says 64 with a question mark.
That was from the last question.
Oh,
I
okay,
answered that.
okay. Tavion says 15. Oh, I think Tavion got it again. Let's see, guys. Let's check. All right, everybody. So look, you start with the last digit, guys. The last digit is 2 to the 0 power, which is just 1. And then the second one is 2 to the first power. The third one is 2 to the second. And then the first digit is 2 to the third. What you have to realize is the one with the 0, it doesn't count. Take it out. Because 0 times anything is just 0. So guys, this one is going to be 2 to the third, 1 times 2 to the third. You don't even need the 1 times 2, plus 1 times 2. And then plus 1. So 2 to the third is 8. 1 times 2 is 2 plus 1. You add it all up and you get 11. Ooh, I don't think anybody got that one. Jules said she got it. I did. Rihanna says, okay. All right, guys. You feel like one more? Because we're going to transition into the operations with these numbers, okay? And once we start doing the operations, guys, it's going to become so much clearer to you. 324 base 5. Come on, I'm rooting for everybody to get this one right. 324 base 5. Don't rush it. Take your time. Remember, use your calculator if your calculator is in your possession. Tavian got 89. Anybody else? 89 says Brianna. 86 says Jules. 89 Erica says. Anybody else? Okay, guys. So let's do it. On this one, 4. I got your question. Okay. So guys, 4 is in the 5 to the 0 place value. 2 is in the 5 to the first power. 3 is in the 5 to the second power. So we do 3 times 5 to the second plus 2 times 5 plus the 4. Remember, 5 to the 0 power is just 1, so you really don't need that. So 5 squared is 25. 25 times 3 gives you 75. 2 times 5 is 10, guys. So you add it all up, and yes, you end up with 89. And just like that, we're done. Guys, that was lesson 2. So now moving on to lesson 3, where we're doing computation and other bases, the 4 basic operations, guys. So lesson 4.3, we've got computation and other bases. I think I'm just gonna do addition and subtraction, and I will let you guys go because I know I'm overwhelming you guys, okay? But let me tell you, once we start, you will see how easy this is becoming to you. So we're going to start with the addition, guys. We're going to start adding first. Now, what you have to remember when you're adding is this. If you end up with a number that is greater than the base, greater than or equal, let me see. If a number is greater than or equal to the base, you must convert that number, okay? Convert it. And the thing is, you have to convert as you go along. Here, let me write this part down. Convert as you add. Okay, so what in the world am I talking about, guys? Remember, guys, addition back in grade school. So in grade school, you had numbers like these, 58 plus 37. This is what you did in grade school. We're in base 10, guys. This is base 10 right here, base 10. So in grade school, this is what you did. 8 plus 7, that's 16. Listen carefully, guys. 16. What did we do? We dropped the 6 and carried 1. Ooh, what just happened? Shazam. What did we do? Okay. We got 16, but we didn't write 16 down. We dropped the 6, the 1's digit, and carried the 1. And then we would proceed with the problem. So this is a similar process, guys, okay? So let me show you what I'm talking about with some examples. I like going back to grade school to jot your memories. So guys, here's the first example. You have 3, 3 plus 1, 3. And by the way, this is in base 4. So let's write the base. We're adding these two numbers in base 4. All right, guys. So because you're in base 4, all the digits in the answer must be less than 4. So guys, here we go. 3 plus 3 is 6, but 6 is greater than 4, so you got to convert it. So when we convert 6, we're in base 4. 4 goes into 6 once with what left over? 2. So we drop the 2, carry the 1. And then we do it again. 1 plus 3 plus 1 is 5. But we can't use the 5 because it's greater than the base. So we have to convert it to base 4. How do we convert it to base 4? We do our quick mental division. 4 goes into 5. How many times? 1 with what left over? 1. So guys, there's your answer. I could see, I can see you guys, as in your jaws just dropped. What the heck just happened? What happened? What happened? Okay, here comes another one, guys. All right, 3, 2, base 5. And then we're going to add 4, 3, base 5. All right, ask questions, guys, if you don't get it. So we're gonna add 2 plus 3. That's 5. Can we use the 5? No, we gotta go to the side and convert it. We're gonna convert 5 to a base 5 number. How do we do that? We divide. 5 goes into 5 once, with what left over? 0. We drop the 0, carry the 1. Next, 3 plus 4, that's 7. 7 plus 1 is 8. We can't use 8s. So we're gonna convert it. 5 goes into 8. How many times? Once, with what left over? 3. So there's the answer, guys. No questions from anybody? Do you guys want me to do some more?
Yes.
Okay. All right, guys. So here we are. Let's do one that's a little bit more challenging. 6, 4, 5, base 7 plus 2, 3, 4, base 7. All right, everybody. So let's add 5 plus 4. Let's see here. 5 plus 4, that's 9. Can we use 9? Absolutely not. We got to convert it. The base is 7, so we're going to convert it to a base 7 number. So we're going to take 7 divided into 9. 7 goes into 9 once, with what left over? 2. So you drop 2, carry 1. Oops, 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 oops. Hold on, guys. All right, there we go, carry 1. I'm going to do it again. 1 plus 4 plus 3 is 8. 8 is greater than the base. Can I use the 8? No. So I'm going to have to convert the 8 to base 7. So I take the base, which is 7, I divide it into 8, and that's going to give me 1. With what left over? 1. So I drop 1, carry 1. And then last but not least, 1 plus 6 plus 2, that's 9. We already converted the 9, so that's going to be 1, 2, 1, 2, base 7. That's it, guys. Yep. All right, last one, guys, and this is a base 2 number. 1, 1, base 2, plus 1, 1, base 2. So 2 times 1, 1, 1. All right, guys, let's add 1 plus 1, 2. We got to convert that. 2 goes into 2 once with 0 left over. Drop the 0, carry the 1. Now let's add 1 plus 1 plus 1. That's 3. Convert that. 2 goes into 3 once with 1 left over. So drop 1, carry 1. And when you add again, you get 1, 1. And that's it, guys. All right, everybody. So let's look at a practical application of this. 4 hours 26 minutes, 57 seconds, plus 3 hours, 46 minutes, and 39 seconds. Yep, we're adding time, guys. Now, you have to think about time conversion. 60 seconds equals to a minute, and then 60 minutes is equivalent to an hour. So guys, let's do it all together. Now, normally you could do 7 plus 9, carry 1 and add, but since we're doing all this conversion, we might just go ahead and add both digits at the same time. So rather than 7 plus 9, I'm going to do 57 plus 39. Okay, and then convert that. 57 plus 39 is going to give me 96 seconds. Now 96 seconds is actually 1 minute, 36 seconds. So what am I going to do? I'm going to drop the 36 seconds here, and I'm going to carry over the minute to the minutes column. Any questions, guys? No? Okay, I'm going to keep going. So now we're going to add 1 plus 26 plus 46. So that's going to give me 73 minutes. 73 minutes would be 1 hour, 13 minutes. So we drop the 13 minutes here and then carry the 1 hour. So we add and we get 8 hours, 13 minutes, 36 seconds. And just like that, we're done. Yep, Jules, that's right. So that's an application, guys, of computation with numbers and other bases. All right, so let me go ahead and do subtraction, a few problems with subtraction, and then we can go ahead and end the video as well as class. All right, so guys, the subtraction for subtraction. Let me bring you back to grade school for a minute. Let's say you had to subtract 36 from, well, I'm trying to say something. 55 take away 36, guys. Yeah, I'm trying to say something. Okay, so back in grade school, you learned you could not subtract 6 from 5. You could not take away 6 from 5. Why? Because 5 is less than 6. So therefore, what did you have to do? You had to borrow so that you can make the 5 into a larger number. So where did you go to borrow? The next digit over. You borrowed 1 from the 5, so the 5 became what? 4. What did this 5 become, guys? This is a terrible example. What did the second 5 become? Anybody remember this?
The 15.
Yeah, it would become 15. Now, how'd you get 15? Yeah. How did you get 15, guys?
As you borrowed 1 from 5, and 5's in the tens place, so therefore 10 goes over to the 5, which makes 15.
Mm-hmm. So that 1 that you borrowed is equivalent to the base. What's the base? Base 10. Because if we had a 3-digit number and we borrowed, we would still be borrowing 10, not 100. So what you borrowed, that 1 that you borrowed, is equivalent to the base. It's the same thing we're doing here, guys, with these numbers and other bases. So let me go ahead and get started with the first example. So you're going to do the same thing here. So let's say you have 3, 2, base 4, and you're going to subtract 1, 3, base 4. So guys, similar process. We cannot subtract 3 from 2. We're going to go over to 3, borrow 1, so the 3 becomes 2. Let's see if you guys were paying attention. Okay, hold on a second. There you go. Okay, so this becomes 2. What does this become, guys? What does the 2 become? Anybody?
12.
Not 12. No, we had a no.
So, oh, okay. It's going to be,
Uh-huh.
is it 4 plus 2, 6?
6. Yes. The one that you borrowed is equivalent to the base. What is the base? 4. 4 plus 2 is 6. Now you can carry out the subtraction. 6 take away 3, that's 3. 2 take away 1 is 1. And there you are. All right, guys. So let's do a couple more. Um, 3, 2 in base 7. We're going to take away 1, 6 in base 7. Okay, so we're subtracting again. So I'm going to have to borrow 1 from the 3, so the 3 becomes 2. Okay, what does this 2 become, guys?
9.
9, because the one you borrowed is 7. You add it to the 2 that was already there, so it's 9. 9 take away 6 is 3. 2 take away 1 is 1. And there you are. And here's the last example for tonight, guys. 3. I've got 5, 6, 3, and this one is going to be in base 7 too. Okay. And then we're going to subtract 1, 6, 4, base 7. Obviously, we cannot subtract 4 from 3. So this becomes 5. And this becomes 4. Oh, Shazam. Whoa, did you guys see that? Shazam. Scratch that. You did not see that. Yes, it becomes 10, Alicia. Yes, it becomes 10. Okay, so now we subtract 10 take away 4. That's 6. Now, guys, we move over to the next column. 6 cannot be subtracted from 5. So guess what? We're going to have to borrow 1 from 5. So this will become 4. And the 5 will become, let me grab a different color here. The 5 will actually become 12. And so 12 take away 6 leaves you with 6. 4 take away 1 leaves you with 3. And there's the answer. See, I told you guys you would get this because you're practicing a little bit more. You're feeling more comfortable now. So you're good. Yeah. All right. So I think I'm going to have to stop the recording here, guys.